So my name is Liz,
And I'm Charlie.
and we're members of the NRICH team based in Cambridge. We are absolutely delighted to be leading this webinar for you this afternoon as part of Maths Week Wales, and thank you to Francis who got in touch with us and invited us to do so. We want to just give a quick a shout out, a thank you to Trinity College here in Cambridge, who fund a lot of our teacher webinars so that they're free for teachers to attend. So thank you to them. Throughout the webinar, we'll be inviting you to participate at various points, and we'll do most of that through the chat. Because we're recording, we'll keep our cameras off throughout. There may be an opportunity for you to unmute yourself at some point later to offer a contribution if you'd like to, but mostly we'll communicate via the chat. So what we thought we would do today is have a go at a problem together. Now, as part of our Maths Week Wales offering, we have posted short videos to introduce two problems, one at primary level and one at secondary. And so we thought that in this afternoon's webinar, we'd introduce you to the secondary problem, so that you have some time to get a feel for the task, to have a go at solving it yourselves. So hopefully you'll feel better equipped to think about how you could introduce it to some of your students back at school. We will show you the problem on the website a little bit later on. Charlie, have I missed anything out before we start doing some maths?
I suppose we could mention that it's going to become a live problem next week during Maths Week Wales, which means that we're inviting students to send in their solutions, and we'll invite them to send solutions until around Thursday lunchtime, which will hopefully give us enough time between then and Friday lunchtime to edit the solutions that have arrived. So by the end of Maths Week Wales, we'll be able to publish some student solutions to this problem. Yeah. So we hope you enjoy the problem sufficiently to feel that it's worth giving to your students, and that some of your students can have a go and make enough progress that they want to send in their solutions. It'd be great to have solutions from Welsh schools.
It would indeed. Okay, well, let's get going on the task. So what we're going to do is we're going to share a document with you with the task on. So here is the task, which don't worry, don't feel you've got to read it all through. We will introduce it. So our challenge for you is to find a few sets of 10 consecutive numbers in which the first number is a multiple of 1, the second a multiple of 2, the third a multiple of 3, and so on, up to the 10th, which is a multiple of 10. Now, this is quite a chunky problem. I wonder, Charlie, shall we begin to have a little think about it, and then we can open it out and think all together as a whole group?
Yes, we're going to try and model what you might do in the classroom. Yeah. And later on, we can talk a little bit about that. And by the way, the problem is called multiple surprises.
Oh, I should have said that.
On the sides. Yeah. Okay.
Yeah. Okay. So one of the ways we thought might be good sort of to help us get into this is to start to record some of our ideas. So I'm going to just scroll up to a new page of our Word document here. And perhaps a helpful starting point is to think about recording. And the M that I've used here is just short for multiples. So just by creating a little table here, I hope it'll help us organise some initial thoughts. So Charlie, where might we start with this problem? I mean, this is quite a lot to think about, isn't it?
So my first instinct was, well, try some numbers and see. I had no idea how difficult this was going to be.
No.
And it did occur to me that 39 and 40 are consecutive numbers, where one's a multiple of 3 and one's a multiple of 4.
Okay, well, that would be a nice starting point. Shall we? So I'm just going to put 39 under here under in the multiple of 3 column, and 40 in the multiple of 4. And should we extend? Should we go
to the left?
Lower?
Yes, so 37, 38, yes.
So these are consecutive numbers, of course, that we're being asked. So 38 is a multiple of 2, and of course, I guess every whole number is a multiple of 1. So
yes, and good. Straight away I can see I've got a problem here, because I've used 40 in the multiples of 4 column.
Oh, yes.
But I'm going to need a multiple of 5 and the next number's definitely not. So maybe instead of having 41, I'd like to go down a row and perhaps
Yeah.
see what happens if I've got 45 as my
Okay,
multiple
so
of
the next
5.
multiple of 5. Right, 45. Okay, so let's extend lower, shall we?
Yeah.
44. Okay, well, that's four
So
11s.
yeah, so at this stage, I've got no strategy at all.
No,
I'm just getting a feel for what's and 43 is not a multiple of 3
it isn't. So
because
we've hit a brick wall again there.
yeah, 45 is. So,
Yeah. Okay.
but
So should we go back to the multiples of 5? I mean, generating multiples of 5, it seems quite a friendly and
yes,
accessible place to start, maybe.
yes.
Okay. Well,
So
if we went up to 50,
and straight away I can see I'm going to have a problem because 50 is even.
of course,
So the number before it is going to be odd, and I know enough about multiples of 4 to know that they've got to be
they've got
even.
to be even. So that's not going to work. Okay, so we're
But
looking at,
55 might be.
okay, 55. Let's try. Well, we've got an even, but I don't think 54 is a multiple of 4. It's a multiple of 2.
I play cards sufficiently to know that 4 lots of 13 make a pack of cards and 52 cards. So
Okay,
so it's not worth trying 60
because
because it's
we've
even.
just articulated. Yeah, okay.
But
Should we try 65? Right.
I want to perhaps, model for students that at present I really students often don't see their teachers sort of muddling through
Yeah.
without a strategy but because in a minute I would want to give, in a way, permission to students to work in this
In a
kind of
similar way.
exploratory way.
Yeah, yeah, yeah.
This is looking good, Liz.
It is actually, isn't it? Look, 64 is a multiple of 4. 63, I can tell quite quickly, is a multiple of 3.
321s.
Right. 62 is even. And as we say, multiples of 1, I'm not having a problem with. Well, shall we see what happens if we go the other way then? What if we extend beyond our multiple of 5 to a multiple of 6? Ooh.
But I'm afraid I know that
Oh,
9 sevens is 63.
so
So
67 is
isn't.
not. So
But
we did pretty well.
oh yes, we've got a set of 6 consecutive numbers.
Okay, so at this point, I think it would be really useful perhaps to give you participating a little chance to have a go. I wonder whether you can do better than us. As Charlie says, we've managed to make a sort of a chain of 6. I think it's important for you to get a feel for the problems yourself. Feel for the problem yourself. We're not expecting you to get a full solution at this stage, but have a go.
And I suppose if anybody does get a solution, please remember what was at the top of the sheet, which asks for a few sets, not just one set of 10 consecutive numbers. So the challenge is not over once you found one set.
Perhaps I'll pop the problem back, the text of the problem. But why don't we give you, a few minutes? Anything you come up with, or you notice any strings that you manage to make, please do post in the chat. That would be great. And then we'll come back together in a few moments.
So, Liz, nobody's posted anything yet. And
No.
I'm just wondering whether
Yeah.
people feel that they should wait until they've got a whole solution before posting anything.
Yeah.
And I
Which,
would imagine that lots of students might also feel, often in maths lessons, we give the message that we expect complete
yeah,
solutions.
fully formed ideas.
Yes.
Yeah. Yeah.
And it's quite tricky to convince children that half-thought, half-digested ideas are worth sharing
Yeah.
because they might still offer some hint to how to get to the
Absolutely.
solution.
Absolutely.
Um,
Well, someone has posted a really. I love the way this is phrased as a question. So we've got a set of 10 consecutive numbers in which the first is a multiple of one, the second is a multiple of two, and so on. And the suggestion is, what about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? I absolutely agree. That fully, if it fully meets the criteria of the problem, fantastic. Yes. I guess we would like to draw your attention to the fact that it's asking for a few sets, but that's a brilliant place to start.
and the reason we're asking for a few sets is that we thought some of you might come up with 1 to 10. So
Yeah.
sorry to spoil your fun. But perhaps we should move on.
Yeah, well, okay. So I think, Charlie, what you've just said is really important. This challenge. I mean, this is a hard challenge, and we are absolutely not expecting fully formed solutions at this stage. So when a mathematician is faced with a really tricky challenge, one of the strategies that they might use is to simplify the problem in some way. So, or when I say in some way, they might look at various ways of simplifying. So, if we were to think of a simpler version of this problem and have a go at that, it might give us a bit of insight into this big problem. So, why don't we do that and see where that leads us?
Yes, and I think we'd want to make it very clear to our students that they haven't failed by not being able to answer our problem.
Absolutely.
We've given them a hard problem,
Yep.
knowing that they were unlikely to be able to solve it at this stage.
That's right.
But then we're building up to, we will return to this later on.
Absolutely. Okay, so let's think about how we might simplify. I guess we went straight in to be trying to find a solution to the problem as written,
Yes.
but perhaps we ought to, narrow down. Why don't we just look at multiples, consecutive sets of consecutive numbers where the first is a multiple of 1, second a multiple of 2, and the third multiple of 3?
Well, we had a couple in
We did
earlier.
in our.
We had 37, 38, 39, 61, 62, 63.
So why don't we make a little note of them down here? 37.
And I think the message here is we might learn something about how to solve the original problem by thinking about how we come up with sets of 3 numbers which satisfy the simpler criteria.
Okay.
And the insights that we gain from working on the simpler problem might help us solve the harder problem.
Exactly. So there are 2 examples. They're quite a long way apart. So I wonder whether we might be able to generate some other examples between those 2. Maybe there are some using smaller numbers. What we would really like you to have a little think about now is generating your own sets. So could you please think about, can you find some sets of numbers, consecutive numbers, where the first is a multiple of 1, second a multiple of 2, the third is a multiple of 3.
And please share it in the chat.
Please share them in the chat. That would be really helpful. So we'll give you a bit of time to do that.
And Liz, would you mind typing them up onto the sheet?
I will attempt to do that. Thank you.
go up one. 43, 44.
Thank you. Thank you for your contributions. You're generating them so quickly. I haven't left enough room in my table. So I'm just adding a few more rows. Okay.
Then 49. Oh, I should put it here.
Fantastic.
And then there was 55, 56, 57.
Great. Okay, I like that one as well. So we've got quite a lot of examples now. This is brilliant. And oopsie. Of course, the reason that we are using a table is just so that it's a little bit neater on the screen. Of course, we appreciate in the classroom, you would be doing this on the board or on your flip chart or whatever it is. We're just aware that when we're trying to do things under the visualizer, it can get a bit messy quite quickly. So this is just a slightly neater way of doing it. So, but obviously in the classroom, it'd be scribbling all the way. So Charlie, we've got quite a lot of examples here. Now, I guess as a teacher now, it would be lovely to bring students together. We've got some examples on the board, and we might do a little bit of facilitation. We might be asking a few questions. I guess, I mean, the question I might ask is, what do you notice?
Is there anything that we can notice that might help us create many more sets?
Right.
And for example, if I wanted sets where all three consecutive numbers were in the thousands or in the millions.
Right. Have we got a good way of doing that?
Would it be a simple way that doesn't require a lot of work? But yeah, it'd be interesting just to ask students, what do they notice?
Yes. Yes.
And I think in the spirit of trying to model the kind of conversations you might have in the classroom next week, could you add your contribution to the chat? Anything that you think students might notice or that you've noticed?
I like the again the addition of the question mark, that sort of upwards intonation, which sort of implies the conjecture-like nature. I like that. The sort of this is what I'm currently thinking. There's some work to do, I realise, before I can say that this is always going to be the case. And that question mark conveys that rather nicely. Yeah.
And at NRICH, we often talk about exploring and noticing,
That's right,
leading to conjecturing, which then leads on to generalizing, which sometimes then leads to explaining and convincing and proving.
exactly.
So the word conjecture crops up in a lot of our conversations.
That's right. Yeah.
Would anybody like to have a go at finding three consecutive numbers where the first is a multiple of 1, second is multiple of 2, 30 to the multiple of 3, where all three numbers are in the thousands. Can you do that? Is what we have on the screen offering you enough of a hint of what you might try? Hmm. So it looks like Bill R's conjecture that the first number is always one more than a multiple of 6 seems to be holding.
It's holding.
So perhaps we should move on to another example.
Okay. And see,
I'm rather loath to start making generalizations
too soon.
based on
Okay.
just a little bit of.
So what we could do perhaps is have a look at another simplification of the original problem, but a different simplification. Maybe some of the conjectures we've made here we could apply to the new version.
Yes.
See what happens. Okay then. Well, how about we have a look at multiples of 1, 2, 3, and 4. So consecutive numbers which are multiples of 1, 2, 3, and 4.
Okay, I don't think we need to put any examples.
I think our participants could generate a few.
Yes.
So off you go. So 4 consecutive numbers where the first is a multiple of 1, the second a multiple of 2, the third a multiple of 3, and the fourth a multiple of 4. Feel free to fire out any examples. Don't worry about having a particular method or anything at the moment. But some examples would be brilliant. Thank you.
There's one more, 37, 38, 39, 40. This is really interesting because the first numbers are also still all one more than multiples of 6.
Isn't that fascinating?
This is.
So I wonder if anybody. I mean, you've pointed that out, Charlie. Are there any other conjectures? Is there anything you notice now? I'm thinking about Charlie's previous question. Do you have a way? Is there a way that we could generate lots of examples relatively easily this time? Any thoughts? That's a helpful noticing, Gareth, that it's not working for all numbers that are multiple of 6 plus 1. So you've given us a really nice counter example there, which is really helpful. So what is it? So can we be a little bit more precise then? I wonder.
And we often
alter
talk
our
about conjectures cannot be wrong.
That's right.
Because they are questions.
Yes.
And we sometimes have to tweak, adapt our conjecture.
Yeah.
So in this case, it's not that all the first numbers are one more than a multiple of 6. Is there a different way of describing the first number in each case?
Some helpful further thoughts, I think, here. Gareth, yes, it looks like an even number times 6 plus 1. And Bill, I like the use of exclamation marks as well as question marks now. An even number times 6. So might be another way of looking at that, perhaps, as Bill points out. Are these one more than a multiple of 12? That's interesting that you've both posted conjectures which, although not phrased in the same way exactly, are getting to the heart of the same mathematics. That's yeah.
Yes.
That's nice.
One more than 2 6s is the same as one more than 12.
Exactly.
One more than 4 6s is the same as one more than 2 12s.
Right. Yeah. Nice. So Charlie, we are we're getting lots of insights in terms of the patterns that we're noticing. We're noticing things that will help us generate lots of examples. I wonder whether we could perhaps try one more simplification to see.
Sure.
We've started at 1 each time so far. Shall we shift up a bit?
Okay.
Maybe. Charlie,
we're going much faster than you would go with your students, and we might give students a lot more freedom to test things out. But because we've only got one chat notice board and we're doing this together, we're
being quite directive, aren't we?
We're leading you.
Yes.
Of course, with your students, you might work in a slightly different way. But I think your idea that we don't just explore what happens when we start with 1.
Yeah.
I was thinking that earlier that, I might start at the other end.
Yes.
Because I know that the last two
multiples of 10.
10 and 9 are easy because I've got 99 and 100, for example.
Right.
Or 9,999 and 10,000. And all of a sudden, I could find, because in a way, the 1s and the 2s are going to happen automatically, aren't they? If I've got a multiple of 10,
yes,
then, and it's going to go even, odd. The second number is going to be even.
Yes.
And actually, if I've got a multiple of 10, the 5th number is also going to be a multiple of 5. So starting at the beginning doesn't make sense.
It doesn't really. It doesn't narrow down our options quickly.
But it wasn't obvious at the start.
No, not at all.
But maybe starting with 4, 5, and 6.
Should we have a go? So perhaps we could have some suggestions, please, of sets of consecutive numbers.
And we had 64, 65, 66 earlier.
Yes, of course. Let's put that in. There's a starting point. Any others that you look, we've got a nice this was
no, because this is not even. And
Oh,
might
yeah.
be from the previous.
Okay.
It might be from our previous problem.
Okay. Okay. Um,
Yeah, this is multiples of 1, 2, and 3.
yes. Yeah. Thank you, Liam. 7, 2, 1.
This is a nice test for students. Do they know that multiples of 6 have got to be both even and multiples of 3?
Yeah, it's
As
good,
a
good for
teacher, it's a really
visibility.
nice one because we can check very easily whether the
Whether
digits of the third number add up to a multiple of 3,
Mhm.
and we can check that
Multiple of 5 are obvious. Yeah.
and for multiples of 4, we can ignore whatever is in the thousands and the hundreds column
Yeah.
because we know they'll be multiples of 4.
So we've got 3 sets so far. We've got very large gaps between each one.
So I think I might be saying to students, if you want to notice patterns, you're much better off trying some simple examples and seeing what happens if you can find sort of consecutive sets.
Right.
In the previous page, we had,
Yeah, 13, 14, 15, 16.
so
Those
mean,
no,
here,
yeah.
43, 44, 45,
Yes.
49, 50, 51,
Yeah.
and there are none in between. So this is quite useful to figure out what's going on. So you might want to try some smaller numbers if you're still, or you might want to encourage your children to try smaller numbers because it'll be easier to spot patterns.
Yeah. Yeah.
But well done to Catherine, who came up with
and
2
Liam.
examples in the 2500s.
Charlie, do you think it's worth our while going back to our 1, 2, 3 just to sort of unpick a little bit of what we think might be going on there a little bit more thoroughly in a way that we could possibly do with students?
Sure.
Or shall we leave this more for others to think about? I'm just wondering the best way of proceeding now.
Yes. And with students, you'd give them much more time to
Absolutely.
play around with it. Okay.
Absolutely. Well, should we have a look at our sequences of multiples of 1, 2, and 3?
Yes.
Your point, Charlie, about the consecutive sets is worth honing in on, I think. And I wonder whether we can just unpick that a bit and offer some ways of thinking about it for students.
So do you want...
Shall I? Yeah, I'm going to stop sharing my Word document and instead let's just share the visualizer where we're going to do a bit of scribbling. Okay.
So the way that I think about it is, well, I think it was Bill who talked about, well, one possibility is to have 1, 2, and 3.
Yes.
So we've got the multiples of 1, multiples of 2, multiples of 3. And I know that if I keep adding 2's to multiples of 2, I get more multiples of 2.
I'm going to generate. Yeah, absolutely. Absolutely.
If I keep adding 3's to multiples of 3, I'm going to keep getting multiples of 3.
Yeah.
And if I add 1's to multiples of 1, I'm going to keep getting multiples of 1.
Yeah.
So if I know that 1, 2, 3 satisfy the original criteria,
Yeah. A multiple of 1, a multiple of 2, a multiple of 3.
then if I add 6, I'm going to get 9 here, which must be a multiple of 3 because I've gone up in.
In threes. Yeah.
If I add 6 to the 2, I'm going to get another multiple of 2.
Mm-hmm.
And if I add 6 to 1, I'm going to get another multiple of 1.
Mm-hmm.
So the reason that I'm getting sets which are 6 apart, so I can now predict, is because by adding 6 to a multiple of 1, I'm going to get another multiple of 1. By adding 6 to a multiple of 8, it's the same as adding 2 plus 2 plus 2.
That's right. 3 twos.
And adding 6 to a multiple of 9, it's going to be the same as adding 3 plus 3 plus 3.
That's right. 3 plus 3.
Sorry, 3 plus 3.
Yes.
So we also did multiples of 1, 2, 3, and 4.
We did.
And we could use similar reasoning for that, I think.
Mm-hmm.
So meeting multiples of 1, multiples of 2, multiples of 3, multiples of 4.
Yes.
So let's imagine doesn't really matter where we start. Let's imagine A, B, C, D satisfy the criteria that we wanted.
Yes.
And then we keep adding 4s here.
Mm-hmm.
We're going to get more multiples of 4.
Mm-hmm.
If we add 3s here, we're going to keep getting more multiples of 3.
Yeah.
If we add 2s here, we're going to keep getting multiples of 2. And I'm not going to write 12 ones, but
dot, dot, dot.
And this is the equivalent to adding 12. And this is equivalent to adding 12. And this is equivalent to adding 12. And so is this. So if A, B, C, and D satisfy the criteria, A plus 12 is going to satisfy the criteria, B plus 12, C plus 12, D plus 12.
Yeah. And if they started off as consecutive numbers, because we've added the same to each, they are going to remain consecutive numbers.
And of course, Bill, I hope I've got your name right, Bill R, suggested that, well, we could start with 1, 2, 3, and 4.
Yeah.
And so we're going to get 1 plus 12, 2 plus 12, 3 plus 12, 4 plus 12. And we're going to be able to carry on.
That's right.
Going up in 12s.
So this links right back to our noticings that the very first number in our sequence was always 1 more than a multiple of 12. Yeah.
Yes.
Yeah.
So which is why it's called multiple surprises.
Yes.
Something about the multiples of 4 and how they grow, the multiples of 3 and how they grow, the multiples of 2. We haven't tried multiples of 7, 8, and 9.
Oh, go on then, quickly. Yeah, let's have a go. Yeah.
So let's imagine we wanted sets of 3 consecutive numbers, and we know that 7, 8, and 9 are going to satisfy the criteria.
Yes.
Could you in the chat figure out how many 9s am I going to have to add? How many 8s am I going to have to add? How many 7s before I get the next set of 3 consecutive numbers? So some people have been suggesting that we multiply 7 by 8 by 9. So 7 times 8 times 9 is 504. So that means we've got to add 8 nines, 72 sevens.
7, yeah.
And here we need to add 7 nines,
63 eighths. Yeah.
63 eighths. And here we need to add 56 nines. 72 sevens, it's 504. 63 eighths is 504. 56 nines is 504.
Yeah.
And I wouldn't expect students to say what
I think it might have been Gareth.
Gareth said, where he mentioned that they were the lowest common multiple, because at this stage, the answer seems to be multiply 7 by 8 by 9.
Yes.
So we get 504 plus 7,
Yeah.
511, and then 512, 513,
Yes.
which are indeed multiples of 7, 8, and 9. So this is great because we seem to now have a strategy here, which we can, take back to our original problem.
Right.
And say, oh, if I multiply 1 by 2 by 3, I get 6.
Oh, yes.
And this has gone up by 6s.
Yes.
But then I look at this, and I do 1 times 2 times 3 times 4, and I get 24s.
Ah.
But this didn't go up in 24s.
Yeah. What's going on there? So that's sort of, it's one of those moments when your thinking is interrupted. You've had that surprise. I can't think of the right word. Help me out, Charlie.
But you thought that you were there.
Yeah.
You thought, and there's going to be a bit more tweaking to be done.
There's some adjustments to be done here. My thinking has been upset slightly. Yes.
So, of course, Gareth knows a lot more maths than our secondary students do. And I think it would be reasonable for students to say, oh, you multiply 7 by 8 by 9.
Absolutely.
And then you can show them a counter example where they don't need to multiply 2 times 3 times 4, and there's a little bit more thinking to be done.
And a nice opportunity to introduce the language of lowest common
multiple.
Yeah.
Okay.
Absolutely. Brilliant. So now I guess, Charlie, we could leave our participants with the original version of the problem.
And that's going to be your homework, folks, because we don't have time to finish it off here.
We're not going to look at the solution here and now, but we hope that's given you quite a good insight into this task, so that you feel equipped to potentially.
Shall we?
Yes, stop sharing. Sorry, yeah, let's do that. We hope, therefore, you feel equipped to take this back to the classroom and use it with some of your classes, depending on their age and experience, and that you've got enough now in your to perhaps make some appropriate tweaks where you might want to. So
yes, you know your students a lot better than us.
Right.
We've modelled something that suggests a route towards the problem.
That's right.
Where we've recently met somebody called Manu Kapoor. Do you mind just typing his name in the chat? He wrote a book called Productive Failure. And when we talked to him, he was emphasizing the importance of putting students in a situation where they're aware that they understand the problem, but they don't have enough the skills or knowledge to be able to solve it. And then that prompts the need to know something new. And we're quite taken by this idea that students get their hands dirty to start with, and then they work like mathematicians, and we model what it might be like. And it includes some messy work at the beginning. So there is no shame attached to not being able to answer the problem initially.
That's right.
That is the expectation.
Yeah.
But by working on simpler problems, like we did in this case, we give students an opportunity to make conjectures and in a way that can lead to them being able to solve the problem eventually, which is why we're sort of leaving the problem for you to solve at home because, well, I mean, partly because we know that you know about lowest common multiples. So I hope you didn't feel we were insulting your intelligence by getting you to think on this problem. But we wanted to try and mirror how you might work with your students. And in a way, how NRICH often does this. So we've written recently about a rope model that informs a lot of what we do.
That's
so, Liz, do you want to talk about it?
I will. Thank you. I just wanted to share with you the problem on the NRICH website. I've popped the link in the chat. So this is it. You'll see that there's a principal worksheet at the top should you wish to print something to offer students. And we've set out the problem in exactly the same way as a very similar way to the way that we've introduced you to the task. You'll also see there that there's a video. So we've done a little introductory video of which you could watch yourself and share, or you could share with students directly, but there's probably less need for you to do that given you've been at our webinar here this afternoon. However, the nice thing is that if you teach your maths through Welsh, you might be pleased to know that by the end of the week, or at least on Monday morning, I should say, hopefully by Monday morning, we shall have a version of this video with Welsh closed captions for you. So that's something to look out for. So Charlie mentioned right at the beginning of this afternoon's webinar that this problem will be open for solution. So you can see that there's a submit a solution button. So do encourage your students to send their solutions to us. But Charlie, you're absolutely right. What we have, I hope you can see that actually this problem is a wonderful vehicle through which to introduce students to the idea of lowest common multiple in particular. And of course, they're doing a lot of calculation and fluency work. However, understanding and fluency is not the only part of being a good mathematician. And we'd like to introduce you to what we call our rope model. It was originally developed by researchers in the States, led by Kilpatrick. And what you've got here are 3 strands of a rope representing the characteristics of a good mathematician. So we've got one strand which represents that good conceptual understanding and that procedural fluency, which of course this task lends itself to. However, also, we are at NRICH, we believe that there are 2 other important strands. On the left-hand side here, we are offering 5 aspects of mathematical thinking. So these 5 mathematical thinking skills. So these are the skills that you might bring to bear when you're faced with a problem you've never seen before, like our multiple surprises problem. Charlie mentioned the exploring and noticing. We talked about how we might organise some of our work, in this case, working in a systematic way, perhaps in numerical order, noting down our examples in numerical order. We did lots
of... patterns would have been a lot more obvious.
They would have been a lot more obvious.
Had time to list them in ascending order.
But that's something that you as the teacher could do, taking your students' offerings and helping them organise their thoughts in that way. We talked a lot about conjecturing and making those generalizations. Charlie offered a great representation to help explain our conjecture. And then we could go on. Obviously, our ultimate aim in this particular task was to go to the full version of the problem and be able to convince somebody else that we could generate those sets of 10 consecutive numbers that matched that criteria. So those skills we feel are an essential part of being a mathematician. And then alongside those mathematical thinking skills, we've got our mathematical mindsets. So are we encouraging our students and nurturing their natural curiosity? Are they mathematically curious? What can we do about that in the classroom? Are we encouraging that collaborative approach? Obviously, in today's webinar, we believe most of you are on your own working, so that collaborative nature is slightly more difficult, but we hope through the chat there was a small element of that. Being resourceful is about having multiple ways of approaching a problem at your fingertips, and then being resilient, it is that idea of perseverance. Do I keep going? Do I draw on those multiple ways of working? I don't give up at the first hurdle. So these three strands are really important, and you can see in the picture of the rope, they interweave together, making the whole stronger. And each one is depicted as being the same, width, the same size, the same length, kind of giving us that impression that all three are equally important. So at NRICH, we use this model to help structure the website. So although we've only introduced you to one task in today's webinar, we would love to reassure you that there are hundreds of tasks on NRICH suitable for secondary age students. And let's go to the website just to show you how you might find them. So if I go, sorry, thank you, Charlie. We'll just make the browser a bit smaller again. So here, if you go to the teachers menu and choose secondary, incidentally, the primary site is set up in exactly the same structure. You can see that the three strands of the rope correspond to these three boxes here. So if you are particularly keen to choose a task because of the curriculum content you're wanting to teach, then this is a good place to go. You can use our secondary mapping document, and while we acknowledge it isn't exactly the same as the Welsh curriculum, in mathematics, so much of mathematics is mathematics and undebatable, as it were. We hope you will find that there are problems here and you recognise the language which we're using to describe the curriculum.
And we've got lots of problems on factors, multiples and primes, including multiple surprises,
the one that we worked on.
Which appears in the second column of the secondary mapping document.
You can see at the top here the different strands of the curriculum which you can explore. So there we link tasks that are particularly good for developing the statements from the curriculum. This is your mathematical the conceptual understanding and that fluency as well. However, I'm going to go back to the secondary teacher landing page. If developing some of those mathematical thinking skills is something you'd like to think about in particular, then if you click on that second box, it takes you to this page and you've got a link for each of our 5 thinking skills. So for example, I might want to have a little look at more exploring and noticing problems.
So these are the 5 threads from the rope model.
Thank you, Charlie. And you can see here again, we've organised these according to year groups. So these are still curriculum linked problems, but you're coming at them in a slightly different way.
So in the year 8 column, we should find multiple surprises. There it is.
Right. Brilliant. Yeah. Thanks, Charlie. And then, so finally, if we go back again to the secondary teacher landing page, this third box is taking you to the area of the site where we've gathered our resources according to the mathematical mindset that you might be able to nurture. So for
curiosity was part of the problem, I think.
Definitely think so. Again, you can follow the link and we should find multiple surprises linked here as well. Oh, well, we've got another page. Maybe it's on the second page. Here we go. Yes. There it is. There it is.
Do you want to click on it? Because one of the reasons we knew it was going to be here
yes, good.
Is that this is one of our favourite problems because it does sort of tick so many of the boxes.
Absolutely.
Or, colour so many of the circles. Not every NRICH problem manages to do everything. But we hope the reason we've chosen it for Maths Week Wales is we hope that if your students work on this problem, it will give them an opportunity to work mathematically in all the ways that Liz has been describing.
Absolutely. Finally, we'd just like to flag up that we've created a sort of a dedicated Maths Week Wales page. If I copy that link, I'll post it into the chat quickly. We've linked on that page to multiple surprises, but also to the primary problem, which you could also take a look at because there's plenty there for lower secondary as well. We will pop on this page the recordings of both yesterday's primary webinar and today's here and now, so that you could refer to them at a future date should you wish.
Or you can share it with colleagues who haven't been able to attend today.
Absolutely.
And I think Francis will be forwarding this
Yes.
with other publicity material
Yes.
that accompanies Maths Week Wales.
Is there anything else, Charlie, that you feel we haven't yet mentioned? Thank you, Francis. I'm going to, sorry, I said that and then I immediately talk over you before you have a chance to speak. Would you like to say anything?
No, just a reminder that it's going to be a live problem, and it'd be great to have your students' solutions.
It would be wonderful, yeah.
And Liz, you showed the mapping document. That's sort of the sort of go-to place. If you're new to NRICH, well, we haven't mentioned it. It's all free, by the way.
Yes, we always fail to mention that. It's all free.
The sort of the go-to place for first-time visitors to NRICH would be that mapping document, where we've listed rich tasks which satisfy address some of the threads in the rope model, while at the same time addressing some curriculum topics.
That's right. That's right.
And lots of teachers use that as a basis. They take some of those problems and add it to their school syllabus.
Thank you so much for participating. We've really appreciated you contributing in the chat. I've just popped a link to a feedback form there. We really would appreciate your feedback if possible. It just helps us do a better job, and it gives us, points that we can feed back to our own funders, to Trinity, as I mentioned.
Yes, when teachers enjoy coming to our webinars, it's quite nice being able to tell Trinity their money's well spent.
So thank you. We hope you have a good rest of your evening and enjoy Maths Week Wales next week. Thank you.
Bye-bye.